We can probably get going. Can you folks hear me?
Yep.
Yep.
Okay, thanks. So anybody want to share what, don't think Steve will be joining us, but I can take you folks through what Steve posted and the results that he saw, because the LSTM part of what he shared is almost identical to what I had posted last week. And I'll share the two things that are different, which and those two things obviously have contributed to his excellent score. So we can discuss that. But anybody else want to share anything that they were able to attempt?
I don't have any improvements, but I'm having other problems, and I can talk about those later if you want. Yeah.
Okay, sure. That'd be interesting. Dinesh, any luck with your Siamese?
Not really. I spent yesterday on it. So basically, as I mentioned last time, the model which I was building is somewhat similar to what you have built. So um, all I was doing is trying to compare and trying to like read through it. I found few of the GitHub links where people have coded, but it's quite a complex. So I'm just trying to unwrap them and then re-implement easy way. But I'm nowhere near complete. The A thing is like I'm just trying to understand how Semi's network is going to work, and B is just decoding the code. So I'm
Okay.
in the process, but it's a little bit slow for me.
Okay. No, that'd be good. When you get there, then you'll be able to explain more of it as from the approach you're taking. So that's good.
Hopefully, I'm like the GitHub I have looked at. One of the guy, he is using Glove as well as the word vector, both word to vec. And he's not only creating the I think vector. He's not working only on the words, but he's going down to the character level. Um,
I see.
but I'll give me some time. I'm going to go through it a few times to just to have
Sure.
understanding what exactly he's doing and come back with some explanation.
Yep, sounds good. So Raquel, to answer your question, no, I don't know that whether SAMIS is in the top solutions or not. But one of the reasons for the interest is it's a different approach, and B, it was one of the approaches suggested by a couple of people. One is the Spacey guy who had pointed to a paper and suggested the implementation. The other, I believe, although it wasn't a direct pointer to a paper, but was a reference. I'm thinking by the Quora guys, but I could be wrong. Maybe they refer only to the attention use with LSTMs, but there's somebody else early on in pointers that they said, Siamese is network is often used. I forget the pointer, but those were the reasons, at least, that we discussed early on, that might be one of the interesting different approaches to this problem.
Cool, yeah, just, I don't know, like intuitively it kind of felt may not perform as well as the approaches that you guys are working with. Kind of felt like the objective of SAMIs is slightly different from what you're trying to nail here.
Yeah,
I was just curious if it was on the top solutions, but yeah, sure.
Yeah, haven't looked. In fact, I was going to say probably give it another week or two and then look at the list of the top to compare and see which of the papers and references to some of the top solutions.
Sounds good.
Okay. with that, let's jump to the screen. I had a couple of interesting. First, let's just look at what Steve shared. His results are the first time anybody on the competition from our stuff has broken through the kind of like the 0.2x barrier. He's now at 0.19, and then I'll share what I was able to get to as well. Let's see. Okay. Can you see the Jovian notebook?
Yep.
Okay. So this is in fact identical pretty much, except for two differences with the LSTM notebook that I had shared last week. And I'll point out the two differences, but otherwise identical. So it essentially just, forgetting the fact that, so first thing is it uses the glove vectors. And it turns out that he meaning Steve in the reference notebook also use glove 6 billion, I think 6B versus the 840 MB version that I use. So you can see there's gloves.6b.zip, but again, the length, you get multiple lengths, but I believe he uses the 300 wide or the 300 dimension vectors is my belief. So it's the 300 dimension glove vectors. And then the rest of it, because we went through it, if there are any questions, feel free to ask. But basically, the sequence length is 60 and it's 60 per question. So it'll be like Q1 and Q2. Question 1 is 60, question 2 is 60. The dimension is 300. The max number of words are about 200. For some reason, the guy in the, I as I shared last week, I had hard coded these, but he creates them as some selection from a random subset. This is just to name the LSTM based on the choices you end up with. And then, you just code the encoding, build it, the encoding, and then combine the words from the training and the test data, meaning training questions, question 1, question 2, and text questions, question 1 and question 2, combine all of them, go through some pre-processing. Actually, he doesn't use stemming or any of that, as I didn't either. And then use it to convert it to text using, just convert it to lists, and then convert the test values to text words as well, and then tokenize them. And this is where the max sequence length comes in. So the train data and test data, each of them, the train data 1 and data 2, which are for the 2 questions, each are 60. So it's 120 length of the sequence. And whenever it's less than that, then you pad. And one of the differences between what I'd shared, between my notebook that was shared last week and what Steve had gotten to work was what's the guy, and we went through this last week as well, and at least my understanding continues to be that while he has called them leaky features, there's nothing per se leaky about them. All he does is add the words of question 1 to question 2 and question 2 to question 1, and then find the frequency, if you will, and interestingly, the intersection. So there are just these 3 things that he finds: the length of each and the intersection of the words between questions 1 and question 2, which is built into QDict. And those are the only additional features that he throws in along with the LSTM generated features. And this is something that I had not gotten to work last week, but it again works for me this week. The trick being that you just pass in raw as false, and that allows the usage of apply and these functions applied to the sequence of rows. And you apply some standard scalars because they are numbers that you're getting as a part of this cell output. And then the rest of it is very standard. Pass it through the create the embedding network, create the validation training stuff. The interesting thing is for LSTM, he flips the questions. Therefore, he stacks them vertically, meaning Q1 and Q2 are flipped and then stacked for training as well as for test. For Q1 as well as for Q2, and then he applies the weight validation that we discussed, because the ratio of training, the values of one for the training set is different from that in the test set. And pass.
Can I ask you a question?
Sure.
About the VStack? What do you mean by stacking the questions?
Stacking the question meaning, see, when you, and it'll again, when I show you the thing that I did, which is with convolutional networks rather than LSTM, then it become, because I don't stack there, but so stacking means the data one train, what you're doing is, see here you have a train data of IDX train. So that's train data of IDX train. You build, let's take one example. Yeah, here. So data one train is vertically stacking the train data one and train data two. And if you go back and look at what data one train is,
okay, so it looks like we are appending the question. So first the question one and underneath
exactly.
question two.
Correct. Exactly. So you're just stacking the question two under question one, and then again doing it on the other side, stacking question one under question two.
Okay, so and the reason is to maximize the training data?
Yep.
Okay, thanks.
Right, and then you pass the sequence through the embedding layers, then through the LSTMs, combine them with this magic input, which is nothing but just the a dense layer that you pass the magic input, and magic input is nothing but the leaks that we saw earlier, and the leaks is nothing but the combination of the frequency counts and the intersection of the words. Again, a count. Okay, and then you concatenate the three things: the output of LSTM A, which is, the first input of question one stacked with question two underneath. This is question two stacked with question one underneath. The output of the LSTM A and LSTM B that you get here, and the magic dense, which is the output of the dense layer that you pass the leaks through. And then this is a very simple, just, match norm dropout dense, match norm dropout dense to get your output. And that is, so this combination of leaks is one difference between the LSTM I had shared last week and what Steve has done. The second difference, because that the other difference might also contribute, although I was surprised at the magnitude of the contribution, is he uses early stopping and checkpointing the model. So basically you stop early rather than overtrain, which we kind of, because rather than overfitting. So we kind of touched on it last week. R2 had suggested that as well. He had suggested more than just doing that, but at least this just implements the early stopping part of it. The rest of it is very similar. Just train, go ahead and train, pull back the model. You'll see, even though he has mentioned 200 as the epochs, it stops at around 15, around 17, 18 training epochs. Right? And actually, this is what, about 2 minutes per epoch. So 15 epochs, 2 minutes, about half an hour it gets done. Or even 20, so 22, 40, 45 minutes training. Right? And then you average the predictions because again, like you saw here, you generate the same thing for test leaks, is just doing the same thing, finding out the frequency of the words in Q1 and Q2 and the intersection of Q1 and Q2 from the text. And you do the predictions and you average them. And as a result of just those two changes to the LSTM that I shared last week, Steve's results are very impressive. Public 0.19, as I mentioned, for the first time ever since we started. I think Steve was the first to achieve below 0.2. So kudos. And also the public score is 0.193, which is by far the best that we have gotten so far. And what is fascinating to me is even, just editorial commentary is with BERT and with USE and with SBERT, none of that got us down to where Steve is at with these results, which I find to be incredibly interesting and fascinating. So, even though BERT and stuff is 3 years later than when the competition was done, the best results are still with a good old LSTM with a few additional features thrown in.
Can I ask you the length? Is that basically number of words in the question? The feature length?
Oh, yeah. It's just the length of the combined. You're talking about when the leaks are generated, right?
Yes.
Yeah, I believe it is just the words. Yes, that's my understanding.
Okay.
Here, right? Because you just, this is just a set. So all you do is add to the dictionary questions or question 1I, add questions or question 2I is just adding the question 2 to question 1 and creating, each of these, because the default dict is a set, is just a set, and then you do the reverse. And this is just the length of the dictionary. And this row question 1 is just because, you just create or you just feed this row, which is basically each row of the data frame that you built. And here you're just doing intersection of sets. And therefore you'll find the common words between Q1 and Q2. And here it's just and this is the length of the common words between the questions when combined and duplicates removed, because they are set. Right. So pretty amazing that just
so this structure, QDIC, it basically
so the add is a set operation, so it just adds that. And
so
obviously
it's a dictionary between, so it has like all the
words,
questions and all the pairs of questions. In all the pairs of questions, you find basically how many common words they have.
Yeah, the number and then the common number.
Okay. Thank you.
Yeah. But what to me is fascinating is just that change combined with this early stopping. Remember that Steve's score is at 0.190 or 0.193, right? Now I'll share with you folks.
Before you go ahead, could you go back to the model and show where we are adding that leaky feature? So the leaky feature is nothing but a count of words in each question.
And the intersection. Their intersection.
In a sense, it's almost like a TF-IDF, right?
Yeah, I mean, you can think, but it doesn't. It isn't. TF-IDF though counts how many, if I recall, in the doc, right? In this case, how many words are in a question, in question 1 and in question 2, and then in the intersection of question 1 and 2.
So it's more like just term frequency on a question level basis.
Yeah.
And the first query is interesting, though. You combine both of them, and then he's looking for question 1.
Yes.
So that means that is also covering kind of the intersection of question 2 in that itself.
But it's a set, right?
Oh, the first one is a set.
Each of them is a.
Oh, I see.
Right. Let's go back and look at it. Right. See, the default dict is a set.
Okay.
So qdict of this add this will add it, but what's in qdict would be a set.
Okay. So in other words, basically each row will be unique words of question 1, question 2 combined.
Correct.
And then he is doing his Q1 frequency, which is finding how many of those words in question 1 exist in that. Isn't that just length of Q1 though?
Hang on a second. So here it's row of question 1, right? So you take the so you'll pass in the row, which is the
dict
the question. Actually, no. In this case, the row is this row of that, because remember what he is doing it is for the df train dot apply. So for the training, whatever df train is, right? Df train is the data set to which you pass this function, right? So it's applying this function to each row of df train.
Right.
Right. So df train is not the qdict, right? Df train is the, let's see what is the df train is this, right? So it's the training data frame that you've just read in.
Okay. So that's basically Q1 stacked on Q2, right?
That's just Q1 and Q2. I don't think the stacking is done.
I mean, stacking in the sense meaning there are two columns, basically Q1 and Q2.
2 columns, but next to each other, not stacked.
Right. Okay. Okay.
In a row.
Over there, so what we are doing down below is we are creating another columns, like 3 more columns.
Exactly. 3 more columns. That's correct. Yeah. That's right.
Okay, so and we are calling it as a Q1 question 1 frequency, question 2. If you go a little bit scroll.
So row of question 1 would be in qdict, and qdict actually has, that's why, in fact, in my thing I was or when I played with this, I actually printed out a few items in qdict because I wanted to understand what qdict was. And qdict is actually its entire sentences, or obviously full, because it's questions dot question 1i,
So I would assume it will be the full question one, and then question two, whatever the unique words are would be getting appended to at the end.
Yeah.
But then the row is still going to be just one row of your df train, right? Because you're doing a dot apply there.
Correct.
So then, yeah, isn't still that Q1 frequency? Yeah, I'm not sure what that exactly calculates.
But you'd have to print
yeah,
QDIC
probably, yeah.
to figure out what
Pulling the-
what QDIC looks like, because it looks like, at least when I printed it, and I'm talking from memory, that's the best way to go through it piece by piece, is to print what the dict looks like, and it looks like a sentence pointing to now I forget whether it was words or sentences, but that's what the dict looks like.
Cool. Okay.
Okay, and then you count the length of that dict, which is just using the question one column of the DF train, the first row. And the QDIC entry corresponding to that, you find the length of that, and that's put into Q1 frequency for that. That's what is put in as Q1 frequency in the Q1 frequency column, as Dinesh was saying. That's what is put in.
One question here. Shouldn't be the Q1 frequency, Q1 underscore frequency and Q2 underscore frequency should be the same? Because up above, we are adding a question 2 to 1. And then
No, that's why that not from what I can tell, because you are applying here, DF apply is to DF train, in which DF train is the original training data set that you read, where we have not stacked. So question one is only question one, question two is only question two.
oh, so okay. So in a dict itself, there is a question one, question two, which is appended. When we apply it to the DF.
Yeah, we apply it to the DF train. Yes.
Interesting.
Okay.
Yeah.
Any more?
Yeah, and I was saying, like, if we go, so once we have done these 3 extra columns, what we are doing down in the model is
you said how are we using it? Okay, yeah, that was your other question. So here is how we use it. One, the first way we, by the way, we also don't generate it just on DF train. We also do it on DF test, by the way. Right? Same thing, identical thing on DF test.
Yeah.
Okay. So now, how do we use it? We use it here to generate, basically, this is just stacking it to create the, once we have generated it, then we, stack it. It's the same thing stacked on top of itself. There's no difference. You saw leaks IDX train and leaks IDX train, and leaks IDX val and leaks IDX val. So you don't, it's just 2 instances of the same thing, because the length has to match. But now if you come down here, how do we use it? You use it as another input that you concatenate with the 2 LSTMs when you push it through the final dense network. Right? So you take your input sequences, pass them through the embedding layer, pass them through the LSTM. So you can think of it as 60 tokens of question 1, 60 tokens of question 2, both of them, each of them going through the embedding layers, and then going through a respective LSTM to generate 2 LSTM values, right? One from question 1 and one from question 2. Now, keep in mind that this is question 1 and question 2 stacked underneath, this question 2 with question 1 stacked underneath. And then you take your leaks, which is already stacked too deep and pass it through just a very simple dense network. I mean, or actually I should say it's not even a dense network, it's just like one dense layer. And then you concatenate this LSTM output, this LSTM output from the question 1, question 2, and this magic dense, which is you pass your leaks value through a single dense layer, you take the output of it, you stack all of those, so you're going to get the length of this to be the length of LSTM A, LSTM B, magic dense all concatenated together, and then you pass it through this simple network to get your single final output. So that's where you use it. And then obviously you also use it when you build a model, because you now not only have the sequence 1 and sequence 2, you also have to give the model the input of magic input. And then you have to provide, as you do in a model fit, the leaks train, the leaks val, and then when you apply the here, when you also predict, you have to give it the test leaks as well. So those are the places that gets used. You can go through it. I'll post this CNN version of it. But before I do that, I just wanted to share to what extent just these two things. Remember, Steve has two differences compared to the LSTM network I posted last week. I highlighted one is this usage of this leaks, generating it and using it. And the second thing is early stopping based on validation loss and some patience, meaning, it doesn't change for X number of epochs or whatever. So now if I go to...
I have a question.
Yes.
More general question. So how are the class weights being used exactly? Do you have any idea, like at what point of it? I mean, at what point of the training?
Sorry, could you repeat? How are the what?
The class weights that you had
Oh,
mentioned.
the class weights, yes.
Yep.
In fact, we went through it, Gautam, in some detail, I think 2 lecture back, because there was still an open question, by the way, if you have any insight. But let me share where it gets used. So there are 2. So here uses if RE class weight, then use the class weights. There's one other thing, because the two go together often is what I found. There's also a weight val. Okay. So, and the weight val as well as the class weights are used during the training. And by the way, where are these? How are these values? The values are calculated if you find the short answer is this is the ratio. Somebody can correct me if I'm wrong. Of how many ones are there in the test set, meaning how many are true is duplicates for the test set, and this is the
Train, right?
no, they are actually. I wish I had the way they are calculated.
I think, yeah, it should be from the training. You're basically just calculating the frequency of how many times ones occur and how many times zeros occur.
Right. But actually, isn't it the ratio of test to train? Because that's what you're changing, right? I'll post the exact stuff. I, again, have lost the thread on, or my train of thought on, what ratio is
So do you mean the test labels? We don't have those, right?
to. Yeah, it couldn't be the test, but what then is the...
No, my question was more along the lines of how is
Where
it
is
being
it
used?
used? Yeah,
Yeah.
sure. That I'll show you in a minute.
Because at
Here,
PyTorch also you do the
here,
same thing. You just add it to the loss. But how?
here.
Yeah.
When you fit, you provide a class weight, and the other, the weight val is here. What I searched for and couldn't this is like what you mentioned, typical stuff that we have seen in PyTorch as well and stuff, right? But what was strange, and I am yet to see, I chased down multiple postings on this. None of them were able to explain, and I didn't at the time to play with. We discussed it, and whether you can not have weight val and just provide class weight, and whether the results would be the same, or whether you needed the weight val in conjunction with the class weight. Or you can skip the weight val and just use class weight, because this weight val, it's not clear what additional value it provides by having that specified, but it turns out same as the class weight. And this is how it is used, by the way, to directly answer your question.
So what was the weight val again?
Exactly the same as the class weight. If you look,
Okay.
if you see here, it just is, you make it the length of the labels, but the numbers are exactly the same. Obviously, here you say weight val, when labels validation is 0, then it's 1.3. And that means this is the actual weights for the 1 case, and this is the weights for the 0 case.
So I think this is where the difference is, right? The other one you were just passing in 0.47 and 1.39. And that was used when you were calculating the loss.
Yes.
Whereas when you're passing it here, you're not passing in 0.4 and 1.3. You're passing in and
you're multiplying that value to the validation stuff, you're saying, because the length is, you're multiplying.
No, you're not multiplying it. You're rather, when you're making what is that called? Making a batch, you're picking based on this frequency. So your batch
so you're
becomes
creating
balanced.
a validation. But see, that's where then that led to our earlier question, right? Is if you're using what's that? Can't recall. If you're using the, what was this? When you pick the validation in proportion, what is that term called?
Stratify.
Yeah. When you if it is a stratified split, thanks, Gautam. Then why would this be needed?
No, stratification is not doing the same thing, right? Stratification, all you're saying is if you have these many zeros, these many ones, and if you're saying you have 5, let's say you're stratifying it into 5 folds, then you're just saying that each of those 5 folds should have that same percentage. But when you treat one fold and you're forming a batch, you're still not saying that, oh, my batch of 100 elements should have an approximately equal balance.
So that's what we missed in our previous discussion. So now it becomes clear. You're saying this ensures within a fold that each batch ratio is kept to be what you want it to be.
Right.
Okay. So now we understood weight val in addition to class weights.
I think they're used in 2 different spots. Though I still don't completely understand what difference does it make. Like PyTorch also, like Gautam was saying, that data loaders that you have is one is in picking when you're forming your batch. And when you pass in class weights, that is the one when you're calculating your loss, you try to balance things out.
So this class weight is what I've seen, or at least I've seen, but the weight val was new. But what you say makes sense, Rickle. Thanks.
Yep.
So would it try to make them equal or maintain that ratio? You should try to make it equal, right? 50-50.
Yeah, because you're giving it that frequency, right? So that means you're saying the 0 is the one which is wait, this is class weight. Can you go down? I think if I'm not wrong, it's telling it to pick it with that frequency. So like you're saying, to make it 50-50 is what it should try to do. If I'm not wrong.
Are you saying it would make it 50-50 or it would make it the weights value, the ratio?
Because this basically is saying pick something with that frequency, right?
Right.
That would be automatic, right? If that is the frequency in the original data, even when you pick at random, it should be the same. You don't need weights for that.
No, that's what I'm saying. So I think it uses this as an inverse then, right?
Yeah, it should use this to oversample, undersample kind of
Exactly.
stuff, and
Exactly.
yeah,
To make it 50-50.
yeah.
Because
To balance in, but use the proportion to result in a balance. Okay.
right. Inverse of the
Yeah.
proportion. That's where the frequency comes.
Right. Yeah. So that the data is balanced
Yeah.
within each fold.
Batch rather.
Within each batch. That's the key. Yeah, within each batch. The fold is done through the stratified split. The batch proportion equality is done using this. Okay.
Yes.
Got it. Yeah, because we give it the weight well here when you're doing the validation data. Right. And the class weight here, which is what, as we discussed, is more from when it does the fit, which means it uses it for the loss. Okay. Good. Glad we worked out one other earlier mystery. Thanks to Raquel. Any other questions?
Yeah, I have a quick question. So it's back to adding magic
Yuri, maybe it's me, but you're very faint.
Just a second. Is this better?
Yes, much better.
Okay. Yeah, sorry, it was microphone was low. So when we parsing original question with glove, that does that take like limit? Does it limitize the words?
No.
So
yeah, because even though he says stemmer and forget what else, but both are false, so it doesn't.
Okay. And then yeah, when we
stop words and stem words, but both are false, so it doesn't.
Okay. And then when it's doing comparison, it's also not changing words. So it's using words as is.
When you say comparison,
in the frequency.
Yes. No,
Okay.
it doesn't touch the words.
Okay. All right. Thanks.
So now, if we look, so remember that again to repeat, it is 0.19 on the public and about similar. So let's go down, look at it. 0.190 public, 0.193 private, or 0.19383, so 194. Now, as I keep mentioning, there are only two differences to that guy, which I'd done. Let me take a minute to come up.
In the meantime, I haven't looked at the EDA for this, but how many of these questions like fit within the 60 length token size? Is there like
Yeah, don't know the answer. We'll look into it. I don't recall off the top of my head, but they, don't know.
Okay.
If I were to hazard a guess, I would say there are very few which are very long. So it would be upwards of 80, 90%, I would imagine.
Just curious, like one of the test time augmentation things is like when you're testing, should you be always reading from the front 60, last 60? How about like using somewhere like the middle 60 also as a combination, right? When you're using those words to pass in.
Yeah, that's interesting idea. Of which, but like you said, it depends on whether you may want to do it on those questions where it's greater than 60, right? Because for the rest, it doesn't matter. Because the other reason I think of that a very large proportion isn't more than 60 is because, if all of them were more than 60, no padding would be necessary, right?
Mm-hmm. At least 60, yeah.
Yeah, at least 60. So in this case, there are quite a few, I think. So anyway, the interesting or fascinating thing for me was I was unable to get just that Q and row thingy working. I hadn't debugged why it wasn't working, but to cut, and I hadn't done the early stopping as multiple people commented last week. But look at what my score was. So LSTM shuffle no leak glove, which is exactly what Steve has done, barring those two differences, is 0.32 public, 0.326 private. Now recall, Steve's was 0.190 public, 0.19, I was saying 3 or 4 or something. So look at the extent of the difference from just two things. One, simple, those 3 columns added, and early stopping. Those are the only 2 changes. Well, to be precise, since he used random, there may be a slight difference in the LSTM and in the dropout, blah, blah, blah. But, the extent of the impact of those 2 changes is huge. Right? If you'd asked me, I wouldn't have guessed that they would have made that much of a difference. And it's even more impressive when I'll show you the next thing that I wanted to share. By the way, what is fascinating is how do you explain it, and why just those things make so much of a difference in this case is something worth pondering. I haven't thought too much about it. I just was impressed or wanted to chase down just the extent of the difference seems to me to be very significant. 0.32 to 0.19, those 2 changes.
Will you
Now,
be adding them one by one and kind of looking at your score again as it
yeah, in fact, I wanted
possible?
to go back to do my LSTM and then do it one by one, as you said, and see how much the early stopping contributes and how much. And in my case, since I had hard coded the LSTM, so I can keep the same
Right.
parameters and then change just the early stopping and then just the leaks and see how much it makes a difference.
Right.
Right? Because that's impressive. Now, which lead
Yeah.
me to this very interesting results, which I was working on just today and was able to complete before we started, which completely, I was just very somewhat shocked by this. So I'll show you the result and then we'll go back. If you folks, I don't know how many of you folks remember the CNN network that I shared last week, right? The convolutional networks, 1D CNNs of varying, let's say, widths from 1 to 6, I think it was. And I just added the leaks. And again, I did the early stopping. So just to point you guys to what, without those 2 things, and to Rakel's point, I was thinking of him even as I did that, because I like, shoot, I did 2 together and I'll go back and do what we just discussed, which is do add each one of them. But look at the results without those 2. My results were 0.479 and 487, okay, for public and private. Now look at the results when I've just made just these 2 changes, nothing else changed, 0.17 and 0.173, which is even better than the LSTM network, which just like totally freaked me out. And to show you folks, again, just to recall, all I do in the convolution, if I can say the word, convolutional model is create 6 1D, all same filter size, but I just change, well, not quite. These 4 are the same and these 2 are slightly less filters, less number of filters. And then, just the kernel size varies. So that's why I said it's like, bag of words or one, or again, I keep forgetting the terminology. It's the terminology when you use n words together. But it's just one word. Sorry, Gautam?
Did you mean n-grams?
N-grams, yeah. So this is just 1, 2, 3, 4, 5, 6 because it's all one-dimensional, right? And same activation, same padding is same type, and then just put it through the sequence, run it through con1, then do a global average poll for each of the two. So I have two of them going in parallel, one for each sentence. In this case, I don't stack, as we'll see in a minute. And eventually I just merge the concatenated values for each of the two, question 1 and question 2. So global 1, 2, 3 are all output of each of these, right? And then in this case, the one difference is compared to the LSTM is instead of using the actual values, I use the diff and the mul of the two sequences, right? And then,
is this another difference?
Sorry?
Is this also
Yes.
another difference? Okay.
Not between what I did earlier and now.
Right. Okay. The LSTM and this one.
Yeah,
Okay.
the LSTM and this one, yes. But that difference existed even before.
I see. Okay.
Right. So this different, I mean, this is exactly what I did without the leak and
okay.
without the early stopping.
Cool. Okay.
And my score was 0.42 or whatever I showed you guys a little bit earlier. And then it dropped to 0.17. Right. This is exactly all the same. The one difference is I had coded 64 instead of numdense by 2. But forget, again, no difference between what I had done previously and this. And then, same thing, right? There, if I saw in the LSTM, what had been concatenated was LSTMA, LSTMB, and magic dense. Here it's the diff, mul, and magic dense. And then this network is identical to what goes through what the outputs of LSTM went through. So that there is no difference. And then obviously apply the class weight and the validation weight and train, blah, blah, blah. And off we go. And I get the result of 0.170 and 0.173. So it seems as if, a few things, and of course, a lot more, or need to analyze to figure out the reason that this simple CNN stuff in this particular application seems to do even better slightly than the LSTMs. Any ideas or thoughts on that? What could be potential reasons? Or, in this case, it seems like just simple n-gram CNNs 1 through 6, and those features gives you very good results. And by the way, same thing for LSTM too. Much better than anything else using USE or even BERT. Of course, I have done just the USE and SBERT, but Steve had done the actual BERT and he was at around 0.29, but with his current LSTM thing is at 0.19. Sorry, Yuri, were you going to say something?
Well, I have like two thoughts. First of all, like you can probably add those magic layers into BERT-based model also.
Yeah, that's something Steve was planning on trying once he got some results. So it would be interesting to try that as well. Yep.
Okay. Yeah, and I don't have an explanation, but the only thing is that I guess maybe the model, the way it's set up, normally just like it's not set up to count well, so that's why explicit features help. But
yeah, and especially the intersection makes a lot of sense, right? I mean, again, in I forget whether it was in a in the hands-on machine learning class we were talking about what helps, and anything that helps the model learn easier seems to help. And like you said, none of these, neither the LSTM nor even the CNN, or I doubt even BERT or any of these is tuned in any way to be sensitive to the number, because we also equate we make the numbers the same anyway because we give it to the sequence with LSTM or even with CNN, right? So separately providing not just the individual numbers, but I was also fascinated by, and it'd be another interesting experiment to try would be to provide just one or just the intersection and see how much that contributes, and drop the Q1 Q2 frequency and see whether most of the benefit is from the intersection, which would be my guess, but I could be wrong, and drop the Q1 Q2 counts. And obviously we have the answer already with all three, and we could just do that, and that could be another ablation study to try, because that would give us an interesting thing of, is it the individual counts that add the most value, or is it the intersection counts that help us the most, or about the same? No idea, but that'd be interesting thing to try.
Yeah, the individual count I still don't understand fully, but if we say that the intersection is playing a huge role, isn't that like the most naive way of kind of seeing whether one question is same as the other question, finding the number of words that occur in both?
Are shared. No, that's you're exactly right. That's what I was thinking too. That wow, that, but putting that in along with some of this
Right,
complexity
right.
seems to help it learn so much better.
Mm-hmm.
So much meaning mine, to me at least, very significant, right? Because we are at 0.3, 0.4, and it drops to 0.19, 0.17.
Yeah, I think like early stopping is the one which I'm very curious about. I don't know if your previous one had that as a major issue before even the Q1, Q2 intersection.
Yeah, that's true. I mean, that's why I said that those were two
Right,
changes.
right.
So yeah, and it would be interesting to see whether most of the benefit came from not just overfitting to the current questions.
Right, right. And that ask general question based on that. Does anyone know a good resource or a rule of thumb of how to go about using early stopping the right way? Like, how do you set patience, or is there like kind of a ballpark range that you usually set, use? I kind of no idea. It's more of a someone uses it, I just use the same numbers sort of a thing. Does anyone have anything on that? Or does someone use it, and is there like a certain procedure about how you go about using that? Any insight on that? Cool.
Yeah, it's a good question. Of like, how much should patience be and stuff, right?
Right. And I mean, like, I think this is one of those things we was talking about before, right? When you make changes, you kind of make them, if you're making multiple changes, you kind of do the orthogonal ones so that they don't affect each other. But early stopping is one of those which is clearly not it does like multiple changes that is happening there. So that's even more confusing for me to understand, like how you go ahead and set that.
So when you say multiple, you're saying because early stopping has multiple effects.
Yes, kind of helps. Obviously, the overfitting is one issue. Timing is the other issue, right? You save on both those things, and those kind of are like playing with each other. And there are a couple of other things also that are restopping effects. So,
Yeah.
uh,
When you say timing, you mean just the number of epochs?
that probably has an orthogonal part of it.
Right.
So
Then
that
what?
shouldn't be. I can't
Yeah.
remember at the
When you say timing, then I was
Yeah, that's actually that's true. Timing will be an orthogonal one, but there are a couple of others. I can't remember the top of my head, but
Yeah,
about
but I do agree. I think, I mean,
well,
like
stuff.
you said, that it does have multiple impact. I also can't recall, but it's not a. In fact, I recall from Andrew Ng's course
Yeah,
where he said,
exactly.
"Don't do that because it
Right.
actually has multiple impacts." Now we'll have to go back and look at
Forgot
what multiple
yeah.
impacts is he talking about. I recall that comment he made,
Yeah, but he
but I
doesn't
don't
even.
recall.
Yeah, he also doesn't suggest like how to go about using it or what
Yeah,
the.
yeah. In fact, if I recall, he says, "Don't use it as
Correct.
a."
He suggests not to use it. Yeah.
Yeah. So, I mean, that obviously has not stuck. So, since it's making a difference. But yeah, definitely I'll run the ablation studies because I'm very curious. So, at
Yeah.
least 3 ablations, right? One is each of them LSTM as well as CNNs to do it step by step. And the other one I just thought of that I rattled off was how much does the intersection make a difference versus individual counts? And maybe do one with just the intersection and do one with just the 2 counts and see how it changes.
Yep.
By the way, feel free, I'll post I mean, you can use Steve's notebook. I'll post the CNN notebook shortly after we are done, and feel free to edit and use it and run your own tweaks and studies and share, because we all learn that way. So, but I just, exactly to your point, Rekal, I just thought, wow, that simple thing of counting and figuring out what's common seems to contribute well. Again, to your comment, that combined with early stopping, to what extent each contributes, we don't know, but the combination seems to contribute massively.
Mm-hmm. Yeah, that is kind of crazy, the results.
Yeah. So, Gautam, you want to share your stuff? And
I mean,
I'll
compared to
stop.
this is quite less impressive, but my problem
No,
is
it doesn't
mainly
matter. We'll learn from what you did regardless. It's not the
okay.
score that matters.
Yeah. Okay, I'll share.
Yeah, we can see it.
Okay. So I was able to get rid of my. Okay, I'm still having overfitting problems, but my model is pretty much the same that what I showed last time. The LSTM. So some changes that I made was I made it a single uh, LSTM layer. I mean, it's not separate LSTMs for both the questions. I think this is what the LSTMs that you had shown as well did. They had they had a common LSTM layer for both the questions, and yeah, and then concat and the dense layers. So yeah, the main problem I'm getting is my model is not that bad. I'm getting a validation loss of 0.3, I think, without any of the magic features and stuff. And I think with some regularization, it could perform even better. But the main problem is my test loss is now increased to 0.6 or something like that, 0.5, 0.6. So yeah, I mean, any of you have any idea why validation loss could be low and still test loss is high? Any reasons why that could happen? So I thought that the problem was that since
By
the
the way, sorry,
vocabulary.
Gautam, could you go back? So, are you saying that you you are using 2 different LSTMs for? When I say LSTM, what I mean is, I mean the encoding is the same, but you actually use
No,
two
I use the
separate
same.
LSTMs to generate the encoded value for Q1 and for Q2, correct?
No, it's the same LSTM actually, because that's how Siamese LSTMs work. They have a common LSTM layer.
Okay, but that is a difference because at least what Steve and I are doing are, if you saw, um, using like LSTM as he showed, and even my code of the LSTM is a similar thing because our source is the same. It's two sub LSTM A and LSTM B.
Oh, okay. Yeah, I mean, well, if you think about it, you don't really need two separate LSTMs, right? Both of them are for handling questions, and a question could appear on the left, and the same question could appear on the right. You don't need separate networks to handle the same type of question, right? It makes sense to have a same LSTM and train them together because they are not different type of inputs. They are the same type of inputs. So you want to process them similarly. This made sense to me, so I made them the same,
Mm-hmm.
and it did not give me any drop in performance. I mean,
Okay.
it was still as bad as before. Yeah.
Mm-hmm.
The only
Yeah.
difference is number of parameters, right? In your case, Gautam, you'll be using fewer number of parameters.
Yes, but those fewer parameters get learned much faster.
Not in terms of time. I'm just saying, like in terms of trying to be more expressively trying to fit your use case.
Yeah,
I'm
I
just
mean,
guessing here.
I'm not even talking. Yeah, I mean, it's not even time. It's like the parameters are simply better if you. I mean, if they are trained with more information. I mean,
Yeah,
that's
no,
how
I
I thought
agree.
about it.
I think yeah, that will be like kind of a trade-off. In your scenario, you're using less, and you're saying the same amount of data, so yours should be fine-tuned more like that. Whereas I'm saying in what like Srinivas and Steve were using, the number of parameters are more. So
Mm.
it's kind of like it's more expressive in terms of fitting. I'm just guessing over here. I'm just telling you what I'm thinking. I'm not sure. But this is, I'd be very interested to see what the difference between this and Srinivas's model is. I think that's where we learn to figure out how you kind of move from what you're working with to what is finally achievable with it. I'm very curious to see that.
And like, what was the loss that you guys were getting? Validation loss
Mm, uh, I
before
don't.
the magic input stuff.
Oh, I'll have to go back. I don't. The training loss was incredibly low, zero point 0.1 something,
I mean, yeah,
and
point one. Yeah.
yeah, and that was training loss. Yeah, you're at 0.12, right? Uh, and training accuracy, yeah, it was around 0.9 something, and my validation accuracy was in the 80s, but 80, for the case where I got the best score so far, the 0.17, I think it was around 0.89
Okay.
for the validation accuracy, if I
This
recall.
was
I'm
without the
talking
magic
from
input.
memory. No, that was with.
Okay.
That's the best score now. Earlier, I think it was like 0.84-ish, 82 to 84, somewhere in that range. And I saw it go up to 0.89 when I used this magic features or leaks.
Okay. And this cross entropy loss is the same as the log loss, right? That the uh,
Yep.
that is the metric of the competition.
Yeah, log loss and gross entropy loss are the
Yeah.
same.
Okay. Then yeah, I mean, I'm still confused why my test loss is so much higher than my so much higher than my validation loss.
Is the validation set the same for, I mean, that's from Kaggle, right? That's a fixed set for everyone.
No,
Oh, it's
uh,
different.
validation is something that we make, right?
So then
I
are you
split
guys
my
using the
data and
same standard?
I had tried with point 0.2.
Yeah, so
Yeah,
that's what
ours
I'm
is
saying.
0.1.
No, not
Yeah,
just
I've
that. I
tried.
mean, you could be using different things in your validation, right? It just so happens that it's managing to fit well on your random state of 42 in this scenario.
Okay, that
But
makes sense.
I mean, sorry, what do you mean by that, Rekil? I missed.
Your validation set and Gautam's validation set can be completely different, right? So you guys are not basically evaluating on the same set. So if he gets a certain result and you get a certain result, it's not like comparing the private board score of
But
Kaggle,
yeah,
his and yours, right?
I
but it's
mean,
yeah,
go
go
ahead.
on.
Go ahead.
No, I was saying it's unlikely that, yeah, the difference between different validation sets would be so big, right? It won't matter that much, I think.
I'm not sure about that, actually speaking. It really depends on how you're, are you even stratifying based on like, is your percentages the same there? Stratify data is duplicate. So yeah, I guess that is the same. Yeah, I really think that can play a role. I don't know how much of a role,
Okay,
but
I'll
yeah, I mean,
try a different random state and see. Yeah.
yeah,
But
maybe, yeah, try that and see if that changes something.
Okay.
But in your case, you're saying validation loss is still low, but your test loss is not low, right?
Yeah.
So
Yeah. Initially, I was thinking that uh, since my vocab is trained on train plus valid,
yes.
it might be seeing unseen words in
Uh,
the test. But
oh,
actually,
are you training only on train plus valid or train plus test?
I think that's cheating if you train your vocab on test as well. You should not be doing that, right? It should be just uh, in fact, I changed it to just train, not even valid. uh,
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 I think in terms of
no.
evaluating, you're right. Like I would do first probably train, but when I'm finally going to be like comparing, I would do train plus valid. Maybe not test because yeah, kind of, yeah, true. That is
Yeah.
cheating. Like you never know what's going to come in new. But train plus valid, I don't see that anything wrong in that, right? Because again, like you are randomly choosing what your validation
I
set
mean,
is.
if you want to get an unbiased evaluation
True. That's what I'm saying.
of
When you're
your valid,
training,
yeah.
when you're doing it initially, yes. But I'd say when you finish fixing your parameters and you're
I
going
mean,
to do it
finally,
last
even your
one.
valid becomes trained, right? You train on the whole thing.
Right, right,
And
exactly,
No,
exactly.
but for vocab, why would uh, you? I mean, because the vocab is just the total number of things, words that you want to
because
use.
tomorrow you would be getting new test data, which is not part of, which could be not part of your vocab, right?
New words there to altogether.
Yeah.
Yeah.
So your model should still be able to perform well.
True, but that vocab is limited by your size, right?
But that will change,
Uh,
right? If you add your test
The
set in.
200,000 or whatever the stuff is. Because I think if I recall, and I have to see, but my memory serves me right, the vocab that we build is the total. When I say we, I mean same thing for um, Steve and my model is of the total number of words from training from test, all words from training and test questions.
Correct. So
hmm.
if you add test in there, you're changing the frequency of words, which will change that clipping factor of 2000 words or I mean 200,000 words or whatever you're using, right? And then tomorrow when you see a new word, which in this case won't happen because your test set is fixed, it's fine. But otherwise, if you come across a new word, then you should be handling that and be still able, I mean,
Yeah.
be robust. Your
But
model should
yeah,
still be
anyway,
robust.
the point I was making was that that was not what was causing the problem. Since I was training my vocab on just train, so my valid was still performing decently, but my test was bad.
Mm.
So that was not the issue. Yeah.
Actually, what would be behavior on the unknown words right now?
It's just zero. I mean, the embeddings will be zeros.
Zeros.
Yeah.
Okay.
That's so I've used torch text here. That's what they do by default. So I had to jump through some hoops to. I mean, so what I did was I built a vocab for question one and question two, and then I extended question one's vocab using question two's vocab, and then I equated that to question two's vocab so that both questions have the same extended vocabulary. And then I used glove embeddings, and those became my embedding weights finally.
So
But
terms
yeah,
so if any of those words were not in the cloud pre-training, they would have zeros.
yes, yeah, Ankh. So there is a Ankh
Yeah,
thing
all on.
in the vocab. That's by default 0.
I don't know what. I don't know if you've seen this trick that they used
They are
before.
random weights.
Yeah, random. Yeah. But if there is an easy implementation for that, that might help. Actually, in mapping it, in the question mapping, it should help because it's exactly same word on the left and on the right. Right. So if you have a known word, and you have it in both questions, and you assign it random embeddings, actually that should help because it's a representation of the same word.
Isn't this the case, Yuri? If you have, is it the same word, or is it just if you have two unknown words on either side, they'll get mapped to the same thing, right? Or are you saying?
Yeah. So by default, they will get unknown token. But there was a trick that people used before they started doing like a smaller than words embeddings, like a part of words embeddings. They basically said, well, if an unknown word comes in and we haven't trained on it, we're gonna assign it random vector. And then in multi-dimensional space, random vectors are really far from each other. So if you have two unknown words and you assign it, like, so word comes in, you assign it the random vector, and the second word comes in, it will get random vector. There's a good chance it's really far from all the other words, just because space is pretty big. So if you see the same word second time, it will be exact match.
Correct. Okay, right. Okay.
So you're not getting any benefits of like training or like words being similar, but but at least you're gonna match word to itself.
Right. Okay.
Yeah, I'm not sure how that would be implemented since the embedding weights is something that's fixed. It would be tricky to implement that. Yep. And so initially I thought this torch, since this torch text is abstracting a lot of things, I should just build my own vocab, and I tried even that, and I got pretty much the same results. So this is done from scratch. Like I built a text classification, I mean a PyTorch dataset class, and so this time I used entire glove as my embedding layer. So yeah, the I did not consider the vocab or anything, and it gives me the exact same test results. I mean, pretty close, and even these results are very similar to the previous one. Yep, I still have to figure this out.
Interesting. Yeah, post your notebook and
Yep, I'll
time
post
permits,
this.
then we can poke around and see whether we can figure out some things. Okay, any additional thoughts or comments from anyone? Okay, cool. So I assume we'll have more results to share next week, and then possibly week after we'll take a look at some of the top results and how they got there, or what are some of the techniques people have used to get there, and if, as Rekala, whether some of the things we are doing are showing up among the top results, or are they all XD boost. And I did see generally when I was poking around and doing EDA that there were a lot of handcrafted features, which is another comment I wanted to make. Is it just seems like, despite NLP advancing by leaps and bounds for certain specific tasks, it still seems like handcrafting features is fairly important, even though you tend to see that claim that these are solved problems, because as we saw, even with Bert and that Steve showed, I'm, hopefully he can try it, including some of these features, and see whether he is able to improve the score significantly. So that's another thought based on at least the last couple of weeks. It seems like feature engineering still retains its importance for some specific tasks in NLP. Hasn't completely gone away as you would be led to believe. If anybody thinks otherwise, let me know. But this competition at least made me conscious that, if the task doesn't exactly fall into something that's specially done in NLP, like named entity recognition or squad or something, it kind of falls in between, then, current techniques, you still have to shore them up. Any comments or thoughts on that? Okay, if not, I'll do some ablation studies, and hopefully people have time to also push through. Good luck, Dinesh, with Sammy's. I'm curious to see where it ends up, and same thing for Gautam too. I'm very curious, see where or what you figure out, because as Rekal said, that's how we learn.